Hi, I'm Oliver Gao. I'm the director of Cornell Systems Engineering Program. I have been very fortunate to conduct what I call these systems conversations with our Ezra speakers. So today we're very delighted to have Dr. Bilal Farooq. And actually Bilal is the Canadian Research Chair in Disruptive Transportation Technologies and Services. So he's currently an associate professor in transportation engineering at Ryerson University. So Bilal has been doing wonderful works. So he's interested in understanding the network and the behavior effects of smart mobility and in developing the associated algorithms, models, and I love the most, solutions. So Bilal, it's very nice to have you here.
Thank you for
So
the
yeah, I can see, as we discussed earlier, your work really kind of, covers from human behavior to technology and to services, and in the end, driving towards solutions. This is really amazing. Of course, when I see amazing people doing amazing things, one question I couldn't help asking: how did you get here? So, can you tell us more about yourself, your career development, and also the evolution of your, how things go from the starting point to this wonderful point now you are?
It has been more as a learning exercise. I believe in what I call eternal learning. So for me,
lifelong learning.
Yeah, learning is just important for me, and that curiosity that is driving me, and trying to satisfy that, and that's the driving force. I started my undergrad in civil engineering. After that, actually, I moved to computer science. I did my master's in computer science, and I worked for a couple of years in software industry. And at some point, I realized that the work that I want to do, it should have a larger impact. A larger impact on the society, on our lives, and that's when I tried to look at different areas that could be, I think, useful for me in terms of working, in terms of doing research. And one of the areas that I pointed out was transportation engineering. Actually, I had an interview with my PhD advisor now at University of Toronto, and he asked me this question: so why do you want to do transportation? And my answer to him was a bit unusual, but he liked it. So I told him that I see transportation networks the same as internet, these communication networks where data packets are flowing. The only difference is that if a source is not well behaving on communication networks, we start dropping their data packets to make sure that the network is working efficiently. But we cannot do similar sort of things on a transportation network. So it makes it more interesting, and the behavioral dimension of it is something that is more challenging, analyzing transportation system could be something that will be interesting for me. At the same time, it will have pretty high impact on the society. And he really liked my answer, and he accepted me, and I'm pretty glad that he accepted me. And in my PhD thesis, then I mostly worked on large-scale simulation systems for the city, where we could simulate transportation systems, their interaction with land use systems, their interaction with the environment at a decade level, at a multi-year level, and try to use these tools for planning. Mm-hmm. Then I moved to Switzerland for my postdoc at EPFL. That's where I started working on pedestrian dynamics and looking at very micro level pedestrian behavior, pedestrian flow, so it was still simulation, but at a very different scale. Instead of cities, we were simulating for instance, train stations or evacuation scenarios, or so it was a very at a small scale in terms of space, but the time level aggregation was way deeper. Yeah, so that all this kind of prepared me towards what I'm doing now, in the sense that in the past couple of years, there's a lot of automation coming in. There's a lot of connectivity coming in. There are a lot of new services coming in. So I wanted to stay connected with the behavioral dimension as well as the network dimension. And when this Canada Research Chair came in, excuse me. So with that, there was a perfect opportunity to apply whatever I've learned and produce research that can have high impact.
That's wonderful. Thank you. I was really impressed. With reading your material, and I think you take a approach what people call this learning through curiosity. I think that's very nice. Of course, you have this. You have been doing this Canadian Research Chair in disruptive transportation technologies and services. So now, this is a very big title, very exciting title. So, what's your view? What do you call as disruptive transportation technologies and services? What's your view? What is the current status, and what is the future going to be like?
So, first of all, when this chair was coming in, I had the option of naming it, and there were various names that were thrown around, but I specifically choose disruptive. And for me, disruptive is not just a negative word. It has a positive dimension as well, in the sense that especially in the business side, there's creative destruction and these sort of things that result in something better for the society. And I think in transportation domain, transportation systems, there are a lot of agents, a lot of entities, a lot of directions that they have the potential for this kind of disruption. And my job is to make sure that I'm able to see that disruption, and I'm able to make sure that the positive outcome that comes out of it, and that for the society, that is more sustainable, that's sustainable for long term. And in that context, I've been looking at connectivity dimension. I've been looking at automation. For me, connectivity is something that has a larger impact on the society than automation. Automation is good, but I think we can improve our transportation systems more by focusing on the connectivity. That's why most of my research is trying to exploit connectivity to, say, for instance, develop better routing algorithms, to develop better routing algorithms that are not just looking at travel times, but also looking at environmental dimension as well. How can we reduce greenhouse gas emissions emitted from the system by routing better, by routing cleverly? And that is only possible through connectivity when we can have the state of the system known. Because in transportation, the biggest challenge at the moment is that the complete state of the system, it's not completely known to a certain degree of precision. We can estimate it, but with connectivity, that would be given, just because of the connectivity.
Yeah, that's wonderful. I think it's kind of I think you gave your own interpretation of being disruptive, and I share your view, and I agree with you. Actually, we, especially researchers, right? We like things to be disruptive in a positive way, right? We know that when new things emerge, so society is always divided. There are some early adopters who will embrace, these new emerging technologies, which we call disruptive technologies. But in the meantime, there are groups of people, who could be concerned. Actually, both are very good because on one side, that provide the driving force to push it forward. On the other hand, people who are concerned or kind of not totally believing that actually provide some kind of cautious thinking to that. So speaking of these disruptive transportation technologies, can you give us some specific examples, and then why you think they're disruptive? What do they, disrupt, and also why should we either embrace them or should we be careful about them? So basically, what I'm trying to say, the reason I'm asking this because disruptive transport technology and the service there, it's kind of still a very general term, and you and me, we can stay at this higher level talk. However, I think for our audiences, if we use some examples to illustrate, some really either promising or dangerously promising technologies and why they are disruptive, what sectors could they disrupt, and then even with that, why the society as a whole, we should either embrace them or we should take some actions to gradually do that.
So I think I'll give you two examples, one on the technology side and other on the service side. So yes. on the technology side, let's talk about automation, right? Let's bring in this driverless vehicle technology development that is going on. So I mean, it has a potential for improving our transportation systems in many different ways. For instance, right now we commute to work. We have to drive, or most if people are driving, then they come to work. They park the vehicle in their garage or in their parking lot, and then for the whole day they work. In the evening, they pick up the car again and go back home and park the car at home. There's an approximately 90% of the time when the vehicle is just parked, right? So with automation, it opens up a lot of different other usage of the vehicle while it's not been used by yourself. So, for instance, the same vehicle can be used in a ride-hailing service while you're working. Right? And it has a potential of having in total lesser vehicles been owned by a city than which is currently the case. And with lesser number of vehicles, it has implications in terms of congestion. It has implications in terms of emissions. It has implications in terms of how we live. So it has a lot of potential in terms of improving our lives, changing our lives. But at the same time, there are potentially a lot of negative directions to it as well. For instance, if I can be driven by an automated car, a driverless car, then why am I living 10 kilometers from my work? I can live 40 kilometers away from my work, and I can have a bigger place or quieter place, and I can work while I'm being driven to work in a car, right? So, so basically, I'm encouraging urban sprawl. So, how to make sure that we adapt this technology in such a way that we can have positive outcomes for the city, for the society, for the individuals, but at the same time, these negative impacts, at least they have been properly studied. Their impact has quantitatively been analyzed and been presented to decision makers, to policy makers, to individuals as well, to educate them and let them decide based on the facts that we bring in. So this is the technology direction. On the services direction, again, disruption. You see how ride-hailing services like Uber, Lyft, they have brought in so much changes in any city. There are various examples in the city in the U.S. There's evidence that they've increased level of congestion because there are more single passenger trips being taken through these sort of services. So at the same time, I strongly believe that they have a very strong positive role to play in transportation systems as, for instance, a feeder service for the main public transit system. I'll give you the example of Toronto. So in Toronto, we have these subway lines that start from quite far on east and west, and similarly on the north. We have regional commuter line that starts from various suburbs. So getting access to those stations that are in suburbs, at least for now, most of the trips they are taken by car. You are taking your car to the nearest station where you are parking, and whole day your car is left parked there, and then from there you come to your office, say downtown. What if these trips are being taken by ride-hailing sort of services or shared ride-hailing services? And we have shown that you are able to reduce the number of car trips. You are able to reduce greenhouse gas emissions as well. You are able to provide same level of service as it would be for the access using your own personal cars. So the point that I want to make is that disruption is happening, but directing disruption towards a positive outcome, that is what our job is through our research.
Wonderful. That's wonderful. I think it's kind of, you are saying, disruption is happening, but it's our job to guide, to direct the disruption towards, kind of a direction that's also beneficial to our society. So that kind of naturally leads to my next question: how we as researchers, and especially you, I think you identify this problem, you see this exciting, but could potentially dangerous new development, new disruption, and this kind of disruption, even though it's technology. However, because this technology is having to do with humans who use that service, and this technology have also to do with the infrastructures that support the operation of all these technologies. So which means immediately this becomes a technology-induced social technical complex system. So Bilal, to address those potential environmental problems, safety problems, so how did you do that? What tools, what approach did you use to kind of untangle all these different complexity and shed lights and towards the end of the tunnel, so that people can see, it is exciting, but for general users, yes, it is exciting, and you told me all those kind of concerns. Yes, I say, those are concerns, but how exactly, to what magnitude, to what extent? And in the end, if we want to do the trade-off between the pros and cons, how to do that? It requires quantification. So how did your work help us review all this complexity?
So I mean, there's, as you said, that there's the quantitative dimension to it that we should be very focused on. If you tell people, if you come up with some concrete numbers that people can understand, that is extremely important. But how you come up with that is very important for us as a researcher, and we use a variety of tools for that. So my core training has been on behavioral modeling, for instance. We use tools like discrete choice modeling, or more and more I'm using machine learning for modeling and prediction of certain behavior, then what we do is that we use these models to actually simulate certain phenomena. And actually, even before all this, we need to have some real observations as well. And in case of most of the time, in case of disruptive technologies, they are not deployed yet, so we don't have evidence from the field yet. So we then create experiments in the laboratory, and especially we use tools like, for instance, virtual reality to actually try to mimic or try to simulate a situation where these technologies will be operating, and try to get feedback from the individuals, from the participants on how they behave in this environment. So one concrete example would be that a lot of my research, it's looking into making these driverless vehicles behave more like humans on urban roads. Now, to do so, who is the judge? The judge is the pedestrian who is actually interacting with these vehicles. We don't have very detailed data on it, so we create a simulated environment in virtual reality where pedestrians can actually interact with autonomous vehicles, and we can have very detailed data on where they are looking, how their speeds are changing, how pedestrians are interacting. So all these data then we use for modeling, and those models are then simulated in various scenario settings, or sometimes using simulation-based optimization settings to come up with optimal configuration that would be helpful for policymakers, at the same time OEMs as well.
Great. So, of course, you mentioned in your PhD dissertation you developed simulation tools, especially I think when we are looking at these emergent future technologies or services, it's really hard for us to have some kind of real-world experiment, and then in that case, simulation becomes really a very powerful tool for us to explore into that area. But of course, as researchers, when we use simulation results, like even when we present things to people, one key question people usually ask is that how trustworthy? How can I trust that your simulation is telling me that's going to be the result? So how do you convince people, your audience, that your simulation results, and by the way, I really believe and I appreciate the simulation because I think that's a very powerful tool. But as a researcher, when we communicate, not only our peers who are in this area, but also the general public. So how did you make your simulation to be more convincing, such that people will buy in?
Yeah. That's a great question, and a very important and difficult question. What we do various sort of approaches in this regard. So, for instance, I'll give you an example of my PhD thesis again. So there, what we did, instead of forecasting, we did backcasting. So how? So my PhD started in 2006. So instead of simulating something from 2006 and onward, and telling people that in 2020 or 2025 or 2030 this will happen, we started from 1986. Okay, so from 1986 to 2006, our simulation would predict, and we had data to actually validate those predictions as well, because this is the future that has already happened, and through that. We showed that the kind of results that we are getting, they are consistent with what actually happened. For instance, in these simulations that I was developing, they were for Greater Toronto and Hamilton area. And in those days, between 1986 and 2006, certain key things happened. For instance, how one of the suburbs, which is Mississauga, it developed tremendously, and there was a lot of population growth in that area. And through our simulation, we showed the same pattern that is happening during this time period. We showed how the travel patterns are changing, and just doing this backcasting rather than forecasting. That gave us a very good confidence on the validity of the simulation. So I think this is one aspect that can be looked at. Then other aspects are to be very open about the sources of error, sources of stochasticity, discuss them, outline them, try to come up with some measures to minimize their effect. But yeah, I mean, these are the aspects that could be looked at.
That's wonderful, and I really so essentially you're talking about not only you develop model, you have this simulation result, but you do want to make sure you also look into sensitivity analysis, because some sensitivity analysis could give you totally different conclusions. But one thing I think that makes your work very unique, of course, there are many people doing simulation research, right? There are people simulating how a mechanical system works. Because mechanical systems, they all follow this mechanical, philosophy rules. They're designed. But in your case, in the system that you're simulating, it's really complicated. The major reason because you have humans, right? I think you can simulate how, for example, an engine work. All those car manufacturers, they have all these very high fidelity simulator for the engine performance. That include not only physical but also chemical processes. But now what you are simulating, like for example, pedestrian, right? Their behavior. Of course, there are previous literature giving you some kind of behavior parameters, but still, there's so much stochasticity. Yeah. I think to deal with that, I really like your approach. You talk about this. I think you use this kind of immersive virtual reality. So what power did you find from applying this virtual reality? I find it very exciting.
I think so. When we started, so it comes from the basic technique that we use in cases where real data is not available. So that is what we call stated preference experiment. And in stated preference experiment, it's a very well developed field, and within that there are various tools being used. And when I started working on this area in around 2015 or so, we were in a conference, and one of the Nobel Prize winner, Daniel McFadden, he was the keynote speaker, and during his speech he talked about this aspect, and someone asked him about what is his comment about these stated preference experiments that are going on at the moment related to automated vehicles and the behavior around it. He was of the view that it's very important that we either do these experiments in a real car or in a simulated environment that can actually give a kind of a reference point or kind of a feel of how these vehicles would look like. Mm-hmm. And luckily I was in that I was attending that conference. I was listening to it, and that gave me this idea that why don't we try technologies like virtual reality? And it took us a while to actually develop a kind of a simulator environment that can be as realistic as possible. So, for instance, the simulation environment that we have, if a virtual avatar is coming towards you and you are standing in front of that virtual avatar, that would change direction in a way as a natural pedestrian would do, using the models, pedestrian movement models that we have studied, we have developed, and we have calibrated. Similarly, if a car is coming in and you come in front of it, so it will try to brake and try to save you. So all this dynamics, all this immersiveness, it creates an environment that is second best to reality, right? Mm-hmm. And the fact that we don't have these vehicles on the road, or we don't have access to them in a way where we can conduct these experiments. And if we do these experiments in reality, that won't be actually safe either. So this is the best alternative to that. And actually we can create very controlled experiments in which we can control each dimension of the experiment. We can control the lane width, we can control the speed, we can control the amount of vehicles, we can control whether it's raining or not, we can control whether it's snowing or not, whether it's morning or night, how many other pedestrians are walking around. So all these things that we can control, it gives us a lot of power in terms of creating and understanding human behavior in very rich environment. And so in that context, I think this has been very useful in terms of understanding how people would in reality behave in a very controlled environment.
That's nice. So I really appreciate the view you have, especially when you look at Wall Street, when they are reporting on high-tech industry. So, for example, these autonomous vehicles, they're now at the frontier of this high-tech industry. So kind of, in a lot of people's eyes, autonomous vehicles are technologies, right? I saw you're talking about this training socially aware AVs. I think that's a very, this is the first time I saw this. So I'm very curious, I want to learn more about, so what do you mean? Yeah. By the way, I like it. I feel, the AVs, they're not just going to be, it's just not like a kind of robot or something that carries out what you want it to do, but mainly, what do you mean by social awareness, and how do you train them to be social aware?
So if you give a task to an intelligent machine and the task is such that this is an obstacle, avoid this obstacle, right? And develop an optimization around it, and I'm sure we can develop very optimal system that would be able to avoid most of the time an obstacle. That's how the approach currently is in terms of how we are dealing with pedestrians and how we are training autonomous vehicles to deal with pedestrians. But unfortunately, the pedestrian, it's not an obstacle. It's a human being with a very complex behavior. If you look at today how we behave on the roads when we are walking, I walk everywhere, so I'm more aware maybe about it. But when I'm walking, first thing I do is to not look at the approaching car, but look at the driver of the approaching car. Right? And I want to make sure that I have an eye contact, and we have a silent understanding that this is the right of way for this particular entity, and that they can cross. Right? So there's a lot of social direction to it rather than just simply a mechanical transaction, right? So
that's a beautiful point.
So how to replicate this? It's a very complex problem. It's a very, very complex problem, but we can at least approximate it. Approximate in the sense that when I'm a pedestrian, I'm constantly trying to not just understand, but trying to anticipate what the driver is going to do. Similarly, the driver is anticipating what the pedestrians are going to do. So this anticipation part or this prediction part is something that can be taught to the machines, and that can be taught to the machines in terms of not just how the trajectory would look like based on how the trajectory was before, but more social direction, more awareness direction. So, for instance, if the pedestrian is looking somewhere else but is still walking, right? That we do all the time. For instance, I have my phone on and I'm distracted with my phone and I'm walking, right? So this has a clear effect on my awareness of the environment, and it has a very clear effect on my decisions. But if something is coming towards me, right, I would realize it very later. So incorporating all these details, all these small cues into a machine, that is what I call making them more socially aware.
That's beautiful, and also that's so critical. And so when you explain, I think your example makes perfect sense. Like, a pedestrian crossing a road, and that interaction with the driver, that gives the pedestrian a lot of assurance, right? And then they start walking. So have you imagine, like, if you're crossing the road and you are trying to do the thing you did, and then you look into the car, but there was no driver there. So it kind of feels very weird, and also gives you a lot of uncertainty. Unless, probably, of course, now you talk about this, you train. So essentially, you want to produce as much as possible close to an experience for pedestrian, like they're dealing with a human-driven vehicle. So you laid out all those very beautiful, important points. Now coming to another thing is, what are the solutions? Do we have any solutions?
So before the solution, before I talk about solution, I think one point that I want to mention is that in computer science there is a test that is called Turing test. Right? Mm-hmm. So Turing test essentially is that you have kind of a separation. On the other side, you don't know whether it's a machine or it's a human, mm-hmm. and you are interacting with that entity, and you can't, whether you recognize or you don't recognize whether it's a machine or not. If you didn't recognize that it was machine and you were talking to them and they were so proficient on it, they were so human-like it, that you didn't recognize them. So the machine passed the Turing test. So mm-hmm. I think we need to develop similar sort of Turing test for these AVs, mm-hmm. So that the pedestrian passing by does not feel that whether it was a machine or whether it was a human driven car. Mm-hmm. So that is the ultimate goal. Now on the solution side, so I think we are making progress in the sense that there are at least a couple of researchers in the world who are actually trying to address this issue of making these vehicles behave more human-like rather than pure machine. But I think we're still far from developing a perfectly socially aware AV. But at the same time, tools like virtual reality-based training, they could help us in expediting the solution.
Mm-hmm. Yeah, great. So But I think we've been talking about, we focus on these, these disruptive technologies and services, and how we can, through research, we can perfectize, these things so that it can better benefit human beings, right? That's I feel we want to come out with something that will benefit human beings, right? But now I want probably jump out of this box. Yes, we want to benefit human beings, but do we want to benefit human beings in the short term or in the long run? So the reason I'm talking about this, I want to so instead of course, now when we work on this thing, we're talking probably 20-year or 50-year horizons. But now let's probably jump out and looking at our human transportation evolution like on a century scale, right? So you said before, we walk, right? You said you like walking, right? And walk is essentially zero greenhouse gas emission, right? So and also walking gives you exercise, make you healthy, right? And walking is less stressful. But walking, unfortunately, is less efficient in terms of getting from point A to point B, right? And then gradually, of course, fast forward, that we had horse-driven wagons, speed much faster, right? We can travel to longer distances, and that will enable our economic development, right? And then we fast forward, we have cars. Right, we have cars, but now imagine that if you compare this car-centric mobility, I'm talking about, let's jump out of the transport technology, let's talk about mobility and human society, right? So now we have this car-centric mobility, but in the meantime, you can see that we are, let me stop this, but in the meantime, you can see that we are struggling with, for example, car accidents. We are struggling with youth obesity. We are struggling with greenhouse gas emissions and criteria pollutant emissions. So that impact climate and that impact our health. So of course now we're talking about this future, this autonomous driven vehicle, probably dominated transportation. So from that perspective, I know this is an open-ended question. Yeah. Do you think are we getting better off or are we getting worse off?
It's a very philosophical question. I think so. When we bring in automation, we are freeing up time for something else, right? So humans, they cannot just do nothing.
We need to keep them busy.
I mean, that's us. Our brains, it needs to be kept busy. So if we are freeing up time, that won't just go into waste. That may create opportunities. I'm a very optimistic person, so I would take it like that. That if we are freeing up time, that could be used for other activities, other opportunities, and it is the job of us researchers and society as well to find other activities that would have positive impact on our lives rather than us becoming more obese. Or I think there's still a lot of awareness that is happening, that is building, and especially in the past few years, about health, about environment, and with this awareness that is starting in, I think we will be able to create activities that won't let us become obese or won't let us further destroy the planet. But that's just my optimistic vision.
That's very nice. We are towards the end, but I just just for fun. You said that you said with all these autonomous technologies, we are freed up with more time. And we human beings, we are very intellectual, we are very creative. Since we have more time, we can come up with more creative ideas. So that essentially improve efficiency of our life. Again, taking the example, like when we switched from horse-driven vehicle to cars, our efficiency was tremendously improved, such that the same person, we can do more things. But now I think just kind of very interesting about it. Now we can do more things, but in the end, all the things we do from kind of some very fundamental laws of physics. If we want to do more things, and those more things need to be supported by energy or natural resources, right? So in that case, if we assume that this planet, this Earth, if we assume, and I think it's a reasonable assumption that if we assume that the capacity of all those natural resources and energy, including those we are yet to discover, if we assume there is a capacity there, now because our technology advancement, that enables each one of us to be more efficiently using and consuming those natural resources energy. Yes, we are because of it, we are going to be living a much more colorful, dynamic life. But again, there's going to be natural resource footprint. It's like something. It's like kind of you have this, for example, 10 years of gold or some asset here.
Mm-hmm.
So instead of spending it over 10 years, now you are spending them much faster. Mm-hmm. So that you get much better life, but you take away the opportunities of future generations to live a similar life. So what do you think about that? How can we solve that problem?
Yeah, I think our responsibility for a better life for our future generations, that is something that should be built into our decision making. And at the moment, unfortunately, that's not a mainstream case. But yeah, you're right that okay, we are making things more efficient, but at the same time we have at least we should have certain budget in terms of energy use, in terms of what we are doing to the planet. It's just being more responsible. I think it's just making sure that whatever decisions we are making them such that we are accounting for the future generation and what would they have and what would be left for them. At the same time, we should, I think, create opportunities for or invest in research that would enable the future generations to use as a platform and create new dimensions. So, for instance, if we are investing now in technologies that would enable us to move to other planets, to moon or other locations, that we may not be able to do that in next 10 years, then 15 years, but at least the amount of research that we are able to do that would enable the future generation to take it over and explore possibilities of going beyond planet Earth. So that could be, and actually that would free up, or that would release the stress that is right now on the planet Earth based on our consumption of the resources that are there, the limited resources that are here.
Yeah, so thank you, Bilal. That's actually also why I really like your research area, because you can see that historically and even nowadays and even the future trend, I can see for the majority of the society, for a lot of people, when you talk about AV, when we talk about technologies, people are mostly efficiency driven. Kind of, however, the thing that you just mentioned about, I think it's kind of, we really need to put some guiding principles for technologies such that they are not only towards efficiency, but they need, like you said, they need to be socially aware technologies that will help with efficiency, but more importantly, help our sustainability and human well-being. Yeah, so that's why I feel this your work is really fascinating. Thank you very much, Bilal. So I think that was very nice conversation. Thank you. Yeah.